So I'm about 2 hours outside of London in an area that's known as Motorsport Valley. And that's because 7 of the Formula One teams have major operations here to the tune of 40,000 people working in about an hour and a half's radius of right here. It's a fascinating legacy that goes back to before World War II, where a bunch of engineers came to this area to build airplanes. And now they're in the business of building fast cars. With them, the F1 teams have brought a billion-dollar industry of engineering and manufacturing companies making some of the most advanced technology used in racing. For many years, one of these technologies, simulated driving, has shown the potential to change the sport of F1, from how fast the cars can drive to how expensive they are to make to which drivers shoot to the head of the pack. But sim driving has always been second best to real-life time on the track. But for how long? Is the technology finally good enough to replicate the real thing? And what will that mean for the future of the sport? This is Power Players. I've landed at the headquarters of Williams Racing to meet with James Volwes, who's been the team principal for the last 2 years, inheriting a team in need of a reboot and surrounded by its fiercest competitors in the heart of Oxfordshire. It's funny, as I arrived here and sort of took in this whole notion of Motorsport Valley, I mean, it strikes me, this is where innovation is happening. How did that come about? I mean, you've watched this grow over the course of your career.
Yeah, it's a good question, isn't it? You had really some of the best metal workers in the world, as you imagine, back after World War II, here based around this part of Oxfordshire near Coventry. And Formula One cars back there were metal.
In this factory, a couple hundred people not too long ago, upwards of 1,000 now, is that right?
Yeah, that's right. You may look at it and go, that's a lot of people for 2 racing cars going around in circles, and it is. But it's also an indication as just to how far we're pushing the boundaries of technology and innovation and the detail really we're going into. I think compared to even just 5 years ago, we're in a far higher level of granularity and detail than we ever have been before.
You come over from Mercedes, you become the team principal, you inherit, you walk into a situation that you have said necessitated just breaking everything. Tell me about what you discovered when you got here.
Mercedes is an incredible organization with some really great senior leaders that understand what excellence looks like, and it led on to multiple world championships as a result. But every facility you could ever want or desire was there. There was no concerns about buying it. It was just how long, let's get it in, job done. Williams had a lack of investment for around about 20 years or so, which in our world is a long time. And again, correlates. Our last championships is 1997. And that showed when I joined here.
Technology was central to Val's plans for Williams' revival. But in order to get there, he had to rip up a playbook that had been gathering dust for a while.
It was guided by individuals that had an understanding of how to do various car structures, components, damping systems. You're kind of trying to guide yourself in the night with a flashlight with a faulty battery. What you really need is simulation and structure that provides you clear North Stars. We're going that way.
You've been quoted as saying, you know, you're in the business of fighting giants. You know, you're looking up the table, that you were much further down the table when you got here, you moved up. Your aspirations are much bigger. How does, you know, sort of being, as you've described, a challenger brand enabled you to maybe use technology in a different way?
It's really quite daunting going, we're going to completely change. We're going to destroy that, throw it away. We're going to start again. I had nothing to lose in that regard. In fact, the biggest element was getting people's heads the culture change around, it's okay. We're going to fall flat on our face. We've reached the point where the data is outweighing the number of eyeballs we can put on at any minute. And that's where technology comes in.
As you go about doing that, how do you get the people comfortable with the technology in order that they can embrace it? How do you, because it's changing thinking.
Car data in 2000 was probably 60 channels, maybe 100 channels. We're into tens of thousands, if not hundreds of thousands today. And once you start walking people through the pathway, you can sort of see the eventuality to it. And we're definitely not using all of it. But when you learn how to just understand the correct pathways, you can become much, much better. And that's the journey we're on.
All of this is happening with a backdrop of a business that has changed pretty dramatically over the past few years, most notably with the introduction of a cost cap.
Cost cap, one of the best regulations we ever put in, full stop.
The cost cap limits each team's spending to $135 million a year, but that figure will rise to $215 million in 2026. The implementation of the cost cap not only leveled the playing field, it made simulation a sudden top priority for every team on the circuit as the only cost-effective means of testing, innovating, and improving.
You're assessing where you are. You're using the data more to or fail. You're not just flat out on a treadmill trying to move forward. you're strategic in your thought. So you have to think differently. And the cost cap, what it enabled us to do is it drives efficiency naturally and makes us into a business. And by the way, that's not a bad thing. We're still a sport, we're still independent, we're still Williams, but we're a business at the same time. So every dollar has to be absolutely squeezed for the maximum that can come out of it.
And so when it comes to some of the ways that you find efficiency, clearly simulators are a big piece of that. The technology is eye-popping, the way it has improved, how it is factored into your processes, how it changes the interaction with your drivers.
So you've hit the nail on the head. A key part of driving this forward is simulation.
Simulation generally falls into one of two categories. First is where the driver physically sits inside and drives a physical model on a virtual circuit. It's a very powerful model if you can design it the right way, but the problem is it's real time, so you can only run so many laps. The second type is called offline simulation. It's a virtual model with a simulated driver, meaning it can operate up to 10,000 times faster, get thousands and thousands of iterations in just a few minutes, and explore the many nuances of speed and maneuverability. But the modeling has to be done very carefully because if the driver is made to be too good, the car could end up undrivable in real life. F1 is bracing for new regulations in 2026 that will reshape how every car in the circuit will be built and engineered with hybrid technology. So as much trial and error as possible is paramount.
If you imagine this transition to 2026, we ran on track just this week, the 2026 tyres. But that's on a completely different car to what we're going to have for next year. Right. The power unit sits on a bench in Mercedes HPP. We haven't really seen that. The gearbox is with Mercedes chassis side. They're not components that have come together yet. So we're sort of making our way in a theoretical world to make sure we're pathing ourselves correctly. What I like about simulation more than anything else is it allows you to really think in a completely different way, or potentially find a completely different avenue of thought that you had perhaps not even really explored previously or thought about. Here at Williams, we're behind. There's no doubt about it. I've been public about it. We started our journey much later than others, but our direction of travel is strong.
Is it fair to say you, of late, have been more aggressive in investing in simulation?
I would say probably from the day I got through the door. So the investment started pretty much day two. I just needed a little bit of time to understand where we were.
You needed one day to understand, and then the second day you were ready.
Pretty much. But it doesn't take long.
Simulation has sort of taken on this new sort of cultural import. It has changed the way that drivers grow up into this sport. The acceleration of the technology and efficiency of building lower-cost simulators means the access is growing at an exponential rate as well, which also feeds the needs of F1 from the bottom up. The next generation of drivers have grown up being in sims their entire lives, including Lando Norris, one of F1's current top drivers. And next up is another swath of drivers who have even earlier access to even better sim technology. Drivers like Abbi Pulling, the young breakout star of F1 Academy. Abbi's at the forefront of what may be the next leap for drivers representing the future of the sport. And today she's training for an upcoming race at Base Performance, a simulator company with a primary focus on driver development.
I've been racing since I was 8 years old. There's a lot of things that I love about racing. The adrenaline that you get, the highs and lows, you've got to enjoy both of it. The ladder in motorsport, and specifically the single-seater ladder, you start in karting. I started at 8, and then moving forward, go into cars. So when you're around 14, 15, you can start getting a race license. And that's where you start testing in single-seaters and kind of homing your craft of what you've learned in karting. And it's a whole new ball game. It's very tough, way more physical, way more demanding. With that also comes a cost increase. From karting, you can spend from 30 grand a year upwards to 200, 250 grand. And then going through to single seaters, it can be 500 grand to $1 million if you're doing multiple championships. To then F3, which is 1.5 million to 2 million. And then that's where you get to FIF2. 2 million to 3 million. If you do good enough in that, you'll get the opportunity to be promoted to Formula 1, which sometimes isn't always where you start getting paid, but most likely you'll start earning a salary at that point. For me, costs have always been a really big issue. It's been the thing that's held me back the most. There's drivers that you come up against, male or female. There's some drivers that struggle, some drivers that don't. It's not really specific to gender. You get drivers that can put millions into it and do tons of testing. With motorsport, the problem is it's becoming more and more expensive to do the testing, and that means that drivers are having to go out there and try and perform at their max and try and impress people when they've done very, very little testing against someone that's can, drive the track with their eyes closed, not literally.
Base Performance is plugged into a growing ecosystem centered around Motorsport Valley that they hope will be able to better support the next generation of drivers, carving a path for themselves to climb the ranks. This is something Managing Director James Guest highlighted to distinguish itself in the field of simulation.
So Base Performance, we're very much focused on driver development, driver training, not on the car development and engineering side of the business. So get track familiarization, car familiarization. It's hugely expensive. You have to have a team of people, you've got to get the car there, you've got to rent the track, you've got fuel, tyres. So a test day can cost anywhere from £7,000 to £20,000, depending on the formula you're in. F1's even higher than that. The niche market we're in is providing simulators for the home market, but we also provide simulators for other driver training centres and some race teams that want to focus on driver training rather than just the engineering tools. Engineering tools can be used, but they often use more sophisticated hardware and software, which brings the costs up massively. Our niche is really about training the driver to improve their skill sets and the way that they drive and how they perform, and to familiarise themselves with new circuits.
I ran out of funding in 2021 and joined an all-female series after that, and it was heartbreaking. I've been doing it since I was 8 years old. I think I was 18 at the time, so that's the majority of my life. But when one door closes, another one opens, and I got to continue racing through these all-female series, and they do get a lot of criticism. And at first, I probably was a bit tentative of it, as I grew up my whole life racing against the boys, and I was one of the few females that were around. But I've seen the value in it, and I'm living, breathing proof that it's working. Championships like F1 Academy is, I think, really vital. F1 Academy is a series, it's all female. I think there's now 18 on the grid. It's the reason that I'm still racing. It's giving so many opportunities now to young females, but also it's got so much visibility that it's actually showing younger girls coming through the ranks, oh, actually, I can be a racing driver, and it is becoming the norm. But everyone's dream, I think, is to make it to Formula One, or majority of drivers. So it takes a lot of hard work, and you've also got to accept the fact that you can put in all this hard work and in the end you don't reach that goal. But I don't think any of us ever stop. We will keep continuing. You've got to have that belief at the end of the day in yourself.
In today's day and age, that belief can be reinforced through the real-time feedback of advanced simulation in ways more readily available than ever before. Further, the range in SimTech capabilities varies wildly as the levels of purpose and sophistication begin to ascend to meet the needs of the highest levels of the sport.
I'll go through the levels with rough costings. Probably the cheapest sim you could get is a seat, a set of pedals, and a computer, and you're probably at $5,000. And then it starts stepping up. You can step up to a $10,000, then a $16,000 or $20,000. At $20,000, you're not bad. Probably still don't have motion, just to be really clear, but your steering feels very good. Where you are as a representation of the car is very good. Then you start running out of road there pretty quickly, and you're into $1 million. And then you start running out of road, there's some steps, and then you're into about 12 to 16 million. Welcome to Formula One teams.
Enter companies like Dynisma, which is all in on the car development and serving the innovation needs of the F1 teams directly at the high end of the spectrum.
So, Isaac, any feedback about the car?
I think high speed is a little oversteery.
Okay.
Low speed feels good, and the traction is a little low.
Okay, sounds like we could change your aero balance and maybe your tyre grip.
Isaac Phelps is a young driver who has come in for a test run on a simulator developed by Dynisma, a company led by its founder and CTO, Ash Warren. While working on simulation technology for some of the top F1 teams, Ash recognized a gap in the market and a rapidly emerging need.
I was lucky enough to work at two really fantastic F1 teams. I spent 7.5 years working at McLaren Racing, where I did a huge range of roles, from the wind tunnel to aerodynamic modeling to offline computer simulation. I worked at Ferrari for 3.5 years, exclusively really in the driving simulator. While working at both McLaren and Ferrari, I had extensive experience and exposure to the state of the art as it was then in relation to driving simulation technologies. But what I observed was that there were significant limitations, and in particular, that there was no commercial route to obtaining the sort of technology and performance that Formula One teams needed. So I founded Dynisma really with a view to opening up the market for high-level driving simulator technologies that were sufficient for F1 teams, but also really to be able to take that technology to a much wider market.
However, the cost of alleviating those precious few milliseconds is not for the faint of heart.
We have a range of different systems, typically for a professional motorsport team, including the motion system and the visuals, anywhere from 3 million to 10 million pounds.
But F1 teams don't bat an eyelash when they compare it to the alternative.
In years gone by, it was possible in F1 that there was the teams were able to go and do in-season testing and pre-season testing. There was extensive on-track testing, but this was phenomenally expensive. All of that has moved online, and it has moved into the simulation environment.
You can change the 0.4 to maybe like 0.35. Perfect. I'll just send that, and then we can get him started again.
The return on investment for racing teams investing in simulators is massive. In the past, good simulators were the preserve of a couple of teams who invested heavily in that. But what Dynisma has done to transform the market is to bring along a commercial solution that's actually better than what all the other teams are able to deliver themselves. At the heart of that, again, is our motion generator technology, and this provides the driver with the physical movements and the feedback that they would get from the real car. It's providing them with information about what is going on with the car physics so that they can feel when the rear tires start to slide or under-rotate, or perhaps they get some understeer as they're turning into a corner. So the teams themselves, they know their cars intimately. They know exactly how the aerodynamics perform, how the powertrain performs, and the suspension, for example. So they've all encapsulated this in a piece of software called a vehicle model. This is integrated directly with our motion platform so that when in the physics, say there's a moment of oversteer, within 5 milliseconds, we're able to reproduce that and measure that we've reproduced that on our motion platform, so they get this instantaneous feedback. In addition to the motion, there's of course the steering wheel. So this is another really key input that the driver is using to feel what the car is doing and to control it, of course. Then of course there's the graphics, as you can see behind me. Here we've got a projector setup, but there are many other configurations as well, such as LED walls. And finally, there's also the sound. We're able to excite the whole platform as though an engine is sat right behind the driver. So our motion generator is creating engine vibrations and putting them through the chassis. So as well as like going over bumps or reacting to oversteer or turning into a corner, the driver can also feel the engine vibrations, and this gives them a whole load of extra information that they otherwise wouldn't have.
But what is it that differentiates Dynisma from its many competitors and has earned the trust of the F1 teams aiming to maximize its capabilities?
Latency in particular. And what latency is in the context of a motion system like ours is that any delay that there is from when the vehicle physics are calculated to when we're able to replay those movements through the motion system. And in a Dynisma simulator, this is typically 3 to 5 milliseconds, which is basically imperceptible. In contrast, previous motion simulators could be 20, even 50 milliseconds. And when you do have those sorts of delays, it entirely destroys the illusion and the simulation that the driver is engaged in controlling that car, because they simply can't respond to what the car's doing.
I think we're close to break time for you, just to let you know. He doesn't care. We'll break, Isaac?
Yeah.
Cool. Cool. Yeah, we'll bring you to a stop and pop you down.
Sims have become ubiquitous in the sport and are a key to the future of Formula One. They're narrowing the competitive margins for both the drivers and the teams, ushering in a new era of competition and proprietary customization. How much in your investments and in your colleagues at other teams' investments, how much of your own IP goes into that? How much are they customized?
Watch this space, I'll let you know how it goes. But now you're into what I would call team IP. Yeah. The physics models that run behind it, the time models that run behind it, all of that is very much team IP, not shared between teams, and is the differentiator.
There's some secret sauce here.
Correct.
From team to team. Because I mean, even in reporting this candidly, it's one of the areas where teams are very protective of their IP, and presumably rightly so.
Exactly that. And for exactly the reasons I said. Yes, it's very protected, very confidential in how we operate, how we work. Because, as I said, you get it right, you can be firing on all cylinders. If it's not, you're in trouble.
Yeah.
But you can't go to a supplier and get this information. You have to generate it internally.
It's rapidly evolving terrain, and one that requires keeping an eye even further down the road to see the next, and the next turn ahead, sometimes multiple years out.
Effectively, with the 27 car, there was a meeting that takes place in just a few weeks' time, and that's already fleshing out some pretty serious elements of what we need. Now, we're going to learn a lot when we hit the track running in January and February, but that's how far in advance you need to be thinking of all these aspects to be on time.
Yeah.
And again, when you start, your thought process conceptually is going 2 years ahead of you, if not 3 years ahead of you. That needs simulation to be able to deal with it. The deal I signed when I came here is we're here to win multiple championships. We're not going to get there by just gently iterating there. We have to physically do things in a very different way to how we've done it before, and perhaps even how the grid is doing it today. That means you're forward investing. Everything is forward investing. You do anything short term, you're not going to be able to accomplish those goals of winning championships because you're up against 9 other teams that are working probably at a more efficient rate than you are in that space.
There is a potential, and it feels like you are saying this, that you do have to sacrifice some of the performance in 25 as you look ahead to 26. How do you manage that with drivers?
Undoubtedly, I will look you in the eyes and say we have sacrificed tremendous amounts of performance this year. Tremendous amounts. We've had a good performance, but to give a concept to that, I think we allowed a total of 2 weeks to refine a package that turned on the car. That was it, 2 weeks. I don't want to hear about it again after that. 26. Carlos and Alex are aware that they have a unique, what I feel to be a unique opportunity, as I do, to leave your mark on the sport. But to get there, we're not going to do it by slowly refining this car. We're going to do it by reinventing everything. We have a clean sheet of paper next year. Nothing carries over. There's no bolt, there's not a seat belt, not a steering wheel. Nothing carries over next year. Williams is bigger than me, it's bigger than Carlos, it's bigger than Alex. We're all a part of something that will be a legacy going forward that we'll feel we're a part of. But it's bigger than any 3 of us.
Just how big and how fast is anybody's guess.